Welcome to my YouTube channel. In this video we are going to solve mathematics paper 2 on trigonometry, focusing on the cosine law for papers 2016 and 2020. So one question calculates distance using cosine law. The other one we are going to look at the calculations of an angle using cosine law, plus areas, as well as other questions that come with the trigonometry. Okay, so let's get started. So this was our question for 2016 on trigonometry that had to do with the cosine rule. Okay, so as you may know, our question involves a three-sided shape, which is a triangle, and therefore since there is an angle here that has been given, which is 110 degrees, and we have the two sides pk, which is 5 kilometer and 3 kilometer. So the information about these sides and the angle are given in the statements here on top. Okay, however, it should be noted that the question that they want us to calculate at okay, here it's the distance from P to B. Okay, so P, also P, which is BP. Okay, so we want to calculate BP, that's the distance. So on the trigonometry, when you have been given a triangle with an angle on the sides, and then you check the angle inside. If it is not 90 degrees, or if there is no sign of a 90 degree, it means in order for you to solve either the angle or the side for that question, you cannot use the famous SOHCAHTOA. Instead, you need to use the other two methods, which is the cosine rule and the sine rule. Okay, so SOHCAHTOA, note that it only works in a right angled triangle, or a triangle in which there's a 90 degree. So you don't need to imagine that there's a 90 degree unless it is indicated clearly that there's a 90 degree. Then the SOHCAHTOA can work, or the trigonometric ratios of sine, tan, and the cos can apply. But if there is no 90 degrees, like the way this triangle is, what we have is a 110 degrees. It means we need to solve problems regarding angle or sides, as the case might be, using cosine law, sine law. So in this case, we have been given the distance pk, which is 5 kilometer, and we have been given the distance kb, which is 3 kilometer, and there's an angle 110 degrees here. And what they want us to calculate is the distance from P to B. So what you will notice here is that this question, including what we want to solve for the distance PB, it means it's dealing with the three sides. So we have this side that we want to solve for, this side, and this side. So there are three sides and one angle. So whenever you are dealing with a question in which there is three sides and you are dealing with one angle, including the part that you are solving for, it means what you need to use is the cosine rule and not the sine rule. So look forward to my video on how you know this is sine rule and how to solve problems to do with the sine rule. Okay, so here we are focusing on the cosine law. So for the cosine law, you need to know that the formula is provided in a mathematics question paper, so it is always provided. Okay, so once you open the cover page, there will always be formulas that they give, and the formula you see here is the formula for the cosine rule. Okay, so it has three variables. It has a, b, as well as the c. Okay, so very important. Okay, so let's get started. So for part 1, they want us to calculate the distance BP, the distance from they want us to calculate the distance from B to P. They want us to calculate this distance here. So we have sketched the triangle. This is 3 kilometer, this is 5 kilometer, and then they want us to calculate the distance from B to P. So since we said this is cosine law, remember cosine law was A, B, and C in the formula. So we are going to say how do we identify the sides? So always A will be that side which is opposite to the angle that you have been given. Not that it should always be this side, but depending on where the angle that you have in that triangle is, the side opposite to the angle should be labeled as A. Then for the B and C, it does not matter. Any side can be B or C. So we can label this side as B and this side as C. So the formula, like I showed you, it goes like this. It's A square is equals to B square plus C square minus 2BC cos A. So this is the formula for the cosine law. So if you can't have it in your head, do not worry, because it is always given once you turn the cover page. So let's start the replacement. So it's important here in the triangle that you know where side A should be, because it is always opposite to the angle. The other two you can interchange, that does not affect your answer, but the side where A should be is very, very important, and once you miss it, you get the answer wrong. Okay, so starting to replace. So on the side for A, which is in the formula, we have no distance, and we just have PB or BP, which is the one they want us to find. So we're going to replace. To say here we have nothing, we just have BP. So we square according to the way the formula is. For part B, we have 5, we square. For part C, we have the 3 here, we square, minus 2. We have said B is 5, C we have said is 3. So cos A means the angle opposite to A. So cos, the A at the end means the angle opposite to the distance where the A is. So this is the 110 that we have there. Okay, so we continue with our calculations. So we say our BP square will be equal to 5 square. So you can simply do that on your calculator. You can say 5 to the power 2. You get the answer, it's 25. The same can be done for 3. So 3 to the power 2, you get 9. Okay, then here you can do the multiplication of 2, 5, and 3. So you can say we have the minus here. You can say 2 times 5 it's 10. 10 times 3 is 30. So you say negative 30 cos 110 degrees. Okay, so going further, you can say BP square equals 25 plus 9. Okay, so you can add, this is paper 2, use a calculator. So you say 25 plus 9, you get your answer 34. So you say 34 minus the 30 cos 110 degrees. Okay, so this is BP square. So when you reach here, to avoid making mistakes, I advise that you enter the whole of this expression on the calculator. So it enters, so you simply click 34 minus, then you write your 30, then from there you write the cos, which is indicated there, then you write the 110, so that you get your answer, which is 44. So you enter the whole of this expression to avoid making mistakes. Then this will give you 44.2606043. Okay, so from there we say BP square equals, okay, so remember the idea is to find the BP, not the BP squared. So what we simply do is we need to remove the power 2 here, and the only way we remove the power of 2 is by introducing a square root. So if you introduce a square root on the left side of the expression, you also need to introduce it on the right hand side so that you don't change the mathematical expression itself. So the 2 and the square root cancels, you remain with the BP, then you find the square root of 44 point this number. Okay, so what you do is you are going to punch on your calculator square root, then you enter this number 44.260604 then 3, then equals, you get the answer, which is the 66.652864,368. So the final answer, our examination papers will always have the instructions on the cover page that if they have not told you that you leave the answer in so decimal places or so significant figures, then what you need to do is to leave the first 3 numbers, which is 3 significant figures, as a standard. So we're going to say 6.65. so we round off to 3 significant figures, and since in our triangle the distance we have is kilometers, so even our final answer will be in kilometer. So we did not add the 1 to the 5. Okay, so we are ending with 3 numbers, but before getting these 3 numbers, we check whether the next number is a 5 going up or below. If it's below 5, we don't add anything, we just exclude the other numbers. But if it's 5 or greater, you need to add 1 before you remove the rest of the numbers. So that was the solution for part A. Then for part B, the question is which is for part 2. The question is asking about us calculating the area of the triangle. So this same triangle that we have, what is its area? Okay, so the formula for the area is simply half AB sine C. Okay, so even it is given, you can check after just turn the cover page, there is the formula for the area there of a triangle where there is an angle. So this is the formula, half AB sine C. Okay, that is if the triangle has an angle. If there is height, you use the common formula for area, which is half base times height. But in this one, where we have an angle, we use this one. So what we are going to do is we are going to get the two distances, which is the 5 kilometer and the 3 kilometer to represent AB, and we are going to get the angle in between them as angle for C to find the area. So we simply replace, which is the 1/2 for A, we replace the 5. For B, we replace the 3. Then sine C, you replace the angle 110 where the 2 sides meet. Then you do the calculation. It's 1 times 5 times 3, we get 15 sine 110 degrees over 2. Okay, so you can do the calculations. You can do the calculations on a calculator. You can say 15 times the sine 110. Okay, so you get the answer is 14. So you get the answer is 14.09538931. Okay, then from there, you remember we need to divide this, what we've gotten on top there, with the 2. Okay, so when we divide with the 2, when we divide our answer with the 2, what we get is, when we divide this with 2, we get 7.0476949656. So therefore our area of the triangle, we leave, like we said, 3 significant figures, 7.0, in this case 5. Remember the triangle, the distances are in kilometer, and area we have a square, so it's a 7.05 kilometer. So the reason why we are leaving a 5 here, it's because where we want to end in getting the numbers, which is 3 numbers, the next is the above 4. When it is above 4, you need to add 1 to the immediate number, which is the third, before you exclude the rest. That's why we have 7.05. so those are rounding off rules. So that's our third question, and then that's our second question. So let's check our third question is the shortest distance. Okay, so we want to calculate the shortest distance. What's the shortest? We want to calculate the shortest distance from point K here to PB. Okay, so what's the shortest distance from K here coming to PB? So what you should understand that in a triangle, the shortest distance is always the height of the triangle. So in short, since there is no height in this triangle, we want to calculate the height of this triangle, and that is what the shortest distance is all about. So we are going to say, since we have calculated the area of this triangle, we know it will now be easy for us to find what the height is, and that's the shortest distance. Okay, so I'm going to say the third part. We're going to simply say we find area by saying half base times height. The reason why we are introducing this formula for height is now because they want us to calculate the shortest distance, and shortest distance simply means calculate the height of the triangle. So the area we have already calculated, which is here, it's 7.05, and then half times. So then what is the base? So that's the tricky part that is there when you're calculating the shortest distance. So when you're talking about the base now, it is always, you need to understand the question. The question is saying the shortest distance from K to BP. So the part where they say from this point to this point, the two part, okay, of the question, that's where the base should come from. So it's, since it's from K to P to, since it's from K to BP, or okay, since the question is saying from K to distance BP, so the BP, where the point is going, that's the base. So we get the distance for BP to be the base always. So in this case, we remember that's the first value we calculated for the BP. Okay, so which if you remember very well, the value that we had calculated at first for BP, which is this one. Okay, so this will be our base. Okay, the 6.65. So we're going to say our base is 6.65 because they are saying we calculate the shortest distance from K to BP. Then we multiply by the height, which is the shortest distance actually that we want to find. We don't know it. Okay, so we do our calculations. So it's 7.05 equals, so we do the multiplication here. Okay, so it's 1 times this times h. So we have 6.65 times 1 times h. So we are going to get 1 times this times h. We get the 6.65 h over 2. Okay, so when we divide the 6.65 with 2, what do we get? So we divide. Okay, so when we divide so we want to divide the 6.65 h with 2. Okay, so we're going to say 7.05 equals, okay, so 6.65 divided by 2. Okay, so this one is giving me the answer in fraction form. So okay, you can try your calculator. So I'll do it directly. So this is simply this 2 into 6, which is 3.2 into 6, it's also 3. Then 2 into 5, it's 2, remainder 1. Otherwise 2 into 1, it can't add 0, so it's 3.325 h. Otherwise this one you should find it using a calculator directly. So use the calculator to calculate 6.65 divided by 2, you'll get this. And then since the idea is to find the shortest distance, so 3.325 h, we're going to divide by 3.325 over 3.325. We cancel, we get h equals 7.05 over 3.325. okay, so this should be equal to, so we're going to say 7.05 divided by the 3.325. okay, so what we get in fractional form, it is the 282 over 133, that is the kilometer. So this will be the shortest distance. So please get to note that it's just my calculator which is revealing the answers in fractional form. So use your calculator to divide 7.05 over 3.325 so that you don't get the answer in the fractional form, you get the answer in decimal point, and that's the shortest distance. But it is same as this, but I advise don't leave it in fractional form, leave it in decimal form. So that's how we calculate the shortest distance, which is simply the height of the triangle. Okay, so that's the solution for part 3. Then there's part B. Okay, so there's part B. So part B says solve the equation. So tan theta equals to 0.7. Okay, so for angles from 0 less than or equal to theta is less than or equal to 180 degrees. So this is the question. So this is the question. So solve the equation tan theta equals to 0.7 for 0 is less than or equal to theta, and theta is less than or equal to 180. So we want to find the values of theta. So this one involves finding the angles that you can put here, so that when you place that angle, you get 0.7. Okay, so what we use here is the concept of what we call quadrants. So there are 4 quadrants on the XY plane. There's the first quadrant, the second, there's the second quadrant, the third quadrant, and the fourth quadrant. So in the first quadrant, the relationship is theta, and all are positive in this quadrant. Then in the second quadrant, the relationship is 180 minus theta, and only sign here is positive. Then in the third, it's 180 plus theta, that's the relationship. Then the only one which is positive here, it is tan. Then the fourth is 360 minus theta, and the only one which is positive here is cos. So for us to find these angles, we need, so the first one is always simple. The first angle is always simple. What you simply do, before you can even use this one, you can find the first angle very simple by saying theta is simply equal to, you just find what angle does 0.7, what angle directly gives 0.7. That's your first answer, but there can be 2 or more. Okay, So what you see, so it can be one angle or two angles. So the first angle is always simple, because you simply say whatever you've been given here, you just say shift, or you just say shift tan, or if there is cos for this equation, you always do the same. If it's sine, you do the same. So you say shift tan 0.7. Okay, so it means you want to convert this into an angle. This ratio, what is it in an angle? So that is the shift part. So it means in an angle, this is 34.9920202. So it means your answer here, your first answer, since angles we are told to leave one decimal place, it means you are adding from 9, you're moving from 9. It means since you are required to leave one number after the decimal point. Since you want to leave 9 and the next one is above 5, is above 4, you get the one you add here, you are going to get the double digits 10. So we can't write it, we immediately get the one from the 10 and add here, so it will be 35.0, because once you get one and from a number and give the next, the rest disappear. So this will be 35.0 as the first answer. But this is not the only answer. Remember, the ratio that we have here for 0.7 is positive. So this angle 35 falls in the first quadrant, because their boundaries here. The first boundary is 0. There's a second boundary 90. There's the other one which is 180. There's the 270. Then the 0 actually has also the 360. So here it's 0 and 360. The 90, 180, 270, and 360. So to find the second angle, the first angle is simple. You just say shift tan this number, you get the first angle. Then to find the second angle, you need to check now in the quadrants here. Since this is tan, where is tan also positive? Since the ratio here is positive, so if you press tan 35 on a calculator, you get 0.7, which is positive. Or it may be close, because the actual number for the angle is this one, but we have rounded off, but very close. So the other angle, how you get it, you check in the quadrants. So I said in the first quadrant all the angles are positive. In the second, it's only sine which is positive. Okay, and then in the second it's the only sign, that is positive. In the third, it is only the tan that is positive. So meaning your relationship should be gotten from the third quadrant. Okay, from the third quadrant, meaning 180 plus the 35. So I want you to start to understand me very clearly. So here it means if it's getting the second angle, you need to get it in the third quadrant. Why? Because in the second quadrant you can't get any angle for tan, which is between 90 and 180. You can't get any angle that will give you a positive value. Here in the second quadrant only sine is positive, and then for the third, that's where tan is the only one which is positive. So that's why you can get it. So it will be 180. The relationship here, if you want to get from tan, the relationship in the quadrant for tan is 180 plus theta. So theta is coming from the first angle that you find very easily, which is 35.0. So what you get here is, when you add, is the it's 215. Now there's a trick here. It's 215. Okay, so 215 degrees, which is written properly, it's 215 degrees. Now there's a trick here. So this is actually not part of the solution. Okay, so the reason is that because our question, there's a boundary. They are saying they are only interested in those angles that will give you 0.7, but should be between 0 and 180. So if you try to punch on your calculators, you try to punch 215. Okay, so if you try to punch on your calculator, you say tan 215, the one I found as the second angle, you're going to find that your answer is actually 0.7. Okay, so apart from the 35 degrees, apart from the 35 degrees that we found here, the other angle that can give you 0.7, which is positive, is in the third quadrant, because that's where tan is the only one also which is positive. And the angle is coming out, because of the relationship that is there, is coming out to be 250. So 250 is correct. When you press it on the calculator, it will give you 0.7. That's correct. It's the other angle that can give you 0.7, but it is not qualifying to be the angle, the answer here, because of the limitation. If the angle was from between, they wanted was from 0 to 360, then our answer 215 would have been the solution also. So we would have had two answers. But since the limitation is that they are only interested in angles that should be between 0 and 180, it means you're only going to have just this angle. Okay, so this one becomes wrong because of this boundary. So the only answer is this one. So I explained this so that you understand the next time, because the limit is not always 180, sometimes it's 360, so you need to take note of that. So this was the end of the questions on trigonometry. So please ensure you subscribe so that you can see my other videos, as I'll be posting more often. Thank you very much for subscribing and watching this video. See you next time. I do these solvings in mathematics as well as sciences, and I'm looking forward to even do other subjects. Thank you for watching.